So I'd like to welcome Niki to come and talk.
Thank you. So you get a break from PowerPoint now. This is Sharp Cloud. This is what we're using in the OGTC. This is just the Small Pool Solution Center Sharp Cloud. And if I just flick on, I'll show you what it looks like in full. It's that one. So that's it. That's connecting everything that we have in small pools. It shows all the interactions with the projects, the studies, and with our work themes. When it works, right? So what I'll do is I will just give you an overview of what we mean by small pools. All of these should have something behind them. So by small pools, what we are meaning is a small pool is defined as something of less than 50 million barrels of oil in place. Most of the small pools we're talking about are probably more in the region of anything from 3 to 20. There's 350 of them undeveloped in the UKCS. Some of them are licensed, some of them are unlicensed. This will change shortly because the OGA's 30th licensing round. In terms of what oil is actually in place, there's 3.4 billion barrels of oil and gas that is technically recoverable in these small pools. So it's a big prize that we're going after. And that equates to 135 billion of potential revenue. So that gives you an idea of what the challenge is. That one. It's okay when they're all over this side, it's when they're over that side. So in terms of the small pool strategy, how we're going to unlock this, these are our 5 main areas that we're looking at. I'm going to go into a little bit of detail on the facility of the future and the tieback of the future. These are our key initiatives at the minute. But what we're actually looking at as well is energy integration, so looking at the offshore renewables piece, subsurface and reservoir, and hydrocarbon processing. The challenge is that we have to make sure that these small pools can be developed. There's no technical reasons that they can't be actually developed. There might be other reasons, there might be commercial or contractual reasons. And in terms of the underlying ways we're going to do that, there's automation, obviously digital and data, remote operations, and the circular economy, which I am going to talk about quite a bit here. So, what we have is, this presentation was given on Friday for a Tech 20 event, and we have a call for ideas coming up next week from small pools, which is called Smart Seas. So this was to set the scene really for that, and there'll be people in this room that will be interested in this call for ideas. So as I said, the main thing that we're looking at is tieback of the future and facility of the future, and how these smart communications can actually relate to these 2 particular initiatives. What we're looking at particularly is the subsea Internet of Things and the all-electric subsea future. It plays a key part in this. I'll touch on the call for ideas itself, but all of this is leading into some of our other areas, as I touched on the energy integration and the decarbonisation piece as well. So, tieback of the future. As you can see, we've set this up actually so you can see all the interconnecting themes that come into this. But it means that we can, and the little dots tell you whether it's going to or from, and most instances it's back and forth. So tieback of the future is something that we've had on the go. It's an initiative for the last year, really. We've had a number of different companies involved in this. It's still ongoing. We have a number of proposals and opportunities and ideas that feed into this around this particular area. But this slide shows just how many companies were involved in the original engineering study to look at what we could do for a subsea tieback of the future. How can we do this different? How can we unlock these small pools that are currently uneconomic and make them economic? So it really works around this circular economy piece. in general, the small pools are short life. We're talking 3 to 5 years. So it's no point designing something for a 20-year life, putting it down and then leaving it there. What we need to do is to actually design for disassembly and design for reuse. So we want parts of the system that actually we can put down, we can move on, or after the 5 years, we can move them on to the next field. And then after another 5 years, we can move them to the next field. So around that, we've got to find a way that we can look at this disassembly and reuse part. Now, there's a number of key themes of Tieback of the future. Some of them are things like reusable pipelines. We have to do things differently if we're going to reuse pipelines. Reusable control systems, this remove, refurbish, reuse, a plug-and-play idea so that everything actually interconnects at the subsea drill site, an advanced flow management piece, and the other thing that we're looking at is safety zones. So how can we work with the fishermen to actually redefine the safety zones? So as I say, there's quite a lot of work ongoing in this area. There was a Wood Mackenzie report that was issued, it was the end of last year actually, it was just after the OGA, that actually backs up, it's an independent study that backs up a lot of the findings that we've had from this, the Tieback of the future and what can actually be achieved from this. So the key part of this is the reuse. What we need to do is to be able to find a way that we can reuse the flow lines, we can reuse the wellheads, the control system. And if we can do that, it gives us a 30% subsea capex saving. So it's a real key part of making this happen. But part of that is if we're assuming that we're going to use it twice, 3 times, 4 times, it's all right if you're that first user. How do we make sure that, you know, the second user, the third user, or the fourth user actually has minimises their risks and their minds are set to rest that actually what they're getting is exactly the same as the first company would have. So what we're looking at really here from the smart facilities side is how can we actually monitor these lines? We would like real-time monitoring. We'd like to actually look in the integrity of these pipelines so we can have what is probably an MOT certificate kind of thing of what's gone through the line, how it's behaved, if there's been any excursions from design conditions. For the pipelines, probably the easy one. How do you monitor that all the way through? But also for any of the components in that system, in that subsea system. There's plenty there that, you know, all connect that we don't really have the history of, and we've tended to just leave on the seabed. So that's the Tieback of the future. There's obviously the piece around the data that we need to collect, the communications itself, and just the power side of things. But we have a number of projects that are actually looking at that at the moment. Smart sees that. So takes us to the facility of the future. Now, a lot of these small pools are actually within about 20-25 kilometres of existing infrastructure. So there'd be tieback there, which is why we were looking at subsea tiebacks. But what if there is no infrastructure? What if that infrastructure's disappeared? What if the infrastructure that they're tying into is already at capacity? Or what if this small pool is part of a cluster and it's 100 kilometres away? So here we're actually looking at a facility of the future. This is something we're just about to kick off. We have a group of 8 industry sponsors in this, and it's looking at using a normally unattended installation and using it for small pools. Again, we're talking about something that is 3 to 5 years. So we design it for its normal 20 years, but we move it on. But a NUI is normally in shallower water. It's normally a gas system. What would it take to make it oil? What would it take to put it into deep water? So this group is actually going to look at setting out some design philosophies, some requirements as to how we can actually take this NUI and make it applicable to small pools. It's probably going to be a 9-10 month study looking at this. But some of the key parts of it are remote control and automation of the technologies. We're looking at some of the processing facilities. How can we actually reduce the size of the processing facilities? Obviously, taking out the water depth limitations, but also exploring the minimal manning approaches. How can we take the people off? How can we actually make this so it is anomaly unattended? And really, what we're working with the industry to define is, what do we mean by normally unattended? Are we talking about going out for maintenance every month, every 3 months, every 6 months? What do they actually require? So there's some issues there in terms of smart communication that we can adopt. Obviously, there's all the remote control and automation piece. There's a bit about digital twins. Can we use that? Can we look at being able to use sort of remote what's the word I'm looking for? It's going to go. Control. That's it. Thank you. But for planning maintenance as well, can we actually monitor it through life and be able to look at what maintenance is required, and can we put that into the plan? So that gives you an idea of what the facility of the future is. So, smart seas. It stands, we thought we were being clever, so it's smart communications subsea. In terms of subsea Internet of Things, it's probably not one solution. It's very like Tieback of the future, it's like facility of the future. There is no one silver bullet that's going to get us there. So it's a number of different issues that we need to look at. It's probably going to be some hybrid of different ways of doing this. The one thing that makes it different from, I suppose, existing facilities on this greenfield, we're talking about short life. So we're talking about 5 years. It might just change things a little bit. We're not talking about having to do this for 20 years, because as we take things up and move them on, it could be that we put in a new part of this system that will work. So that's subsea Internet of Things. What we're also looking for is an all-electric subsea future. Total have put in an all-electric subsea tree in the Dutch sector. What this allows us to do is we're removing the hydraulics. So we can either get rid of the umbilical, which is a significant cost to a subsea tieback, or we could reduce the size of the umbilical. We'd need to take things like chemicals or the power from elsewhere, but it gives us that opportunity. It allows us also to look at longer step-outs. It will potentially improve reliability and availability because we're not relying on a hydraulic system. Statoil have installed on Asgard the compressor station. That's just one part of it. There's plenty of other things that will come for these subsea developments. The technologies are out there. There's a number of companies that are actually working on this just now. We've just got to find a way to adopt it and take it into the small pools. Actually, no, I meant to say that. Sorry. So, in terms of what we're looking for, our call for ideas is launched next week, and we are looking for smart seas solutions. They need to tie into our two initiatives, which is Tieback of the Future and Facility of the Future. But we're asking people to give us their ideas how this could work. We have, as I said, we've got a number of different proposals looking at various mechanical aspects of it. This is the part that's missing. It's sort of the data side of it and how we're going to handle that. So it opens next week. Keep an eye on our website, and please feel free to give us your ideas. Happy to discuss this a little bit more afterwards. But yes, thank you for listening.